Breakers are a critical component of the power protection system and are responsible for protecting other components on the electrical grid from damaging fault currents. This is accomplished through a breaker's ability to effectively isolate sections of the electrical system when excessive current levels are detected. Breakers also serve as a means for safely rerouting power without disrupting supply to the end user. Despite the critical role these devices have on overall safety and reliability, breaker misoperation remains one of the most common failures that occur within power systems. Dynamic Ratings Breaker Performance Monitor provides a means of capturing small changes in breaker performance, allowing problems to be detected well before failure occurs. Using Dynamic Ratings Smart Capture technology, the Breaker Performance Monitor can capture waveform signatures as they relate to the operation of the trip and close coils during breaker operations. Through analysis of these captures, a great deal of information concerning the breaker's performance can be learned. Here's how it works. As the breaker is called on to perform a trip operation, current begins to flow in the trip circuit through the 52A auxiliary contact and a plunger begins to be pulled through the coil. This is observed in the waveform as the current starts to rise on the waveform graph. Once the plunger has achieved maximum velocity, the current will reach a peak point and begin to fall. This decrease will continue until the plunger strikes the latch, releasing the breaker's stored energy, allowing the breaker to begin to open. This is visible in the waveform capture as a momentary rise in current immediately followed by the current continuing its downward trend. At this point, the plunger strikes a buffer and begins to rise until maximum current is achieved. While the trip coil is in this maximum current state, the main cam of the mechanism has started to move, and through attachments to linkage, is beginning to open the breaker's main contacts. As the mechanism moves from the closed to open position, linkage attached to the auxiliary contacts opens the 52A switch and closes the 52B switch to prepare the breaker for a close operation. This opening of the 52A switch can be viewed in the waveform as the falling edge of the coil current, which should return to zero once the operation is completed. This changing of the state of the auxiliary contacts is also captured during the waveform capture, as well as the current flow through the breaker's main contacts. The Breaker Performance Monitor captures this waveform and uses it as a baseline fingerprint for normal operation. This provides a reference for comparison of future trip operations and allows for a detailed diagnosis of any variations of breaker performance. This comes in handy when a breaker's lubrication deteriorates. The beginning of the waveform would overlay almost identically to the first operation through the point where the plunger strikes the buffer. However, the time which elapses until the falling edge of the coil current would increase. This increase would also be apparent in the amount of time it takes for current flow through the main contacts to cease. Alternatively, should problems begin to develop with the latch, the point where the plunger strikes the latch would display a higher current level, and the buffer point would move further to the right of the graph, indicating that the breaker took longer to release the latch, delaying the initiation of the main cam. Another common breaker issue is with wiring connections or contacts within the trip circuit. It would be visible in the waveform capture as an erratic current signal on the graph when compared to normal operation. This would especially be apparent during the maximum current portion of the signature and at the falling current edge as the 52A switch opens. Variations in the waveform capture are easily associated with the mechanical performance of the breaker's various parts, allowing many operational deficiencies to be detected in their earliest stages and providing detailed data concerning the diagnosis of these problems. Through the use of smart capture technology, the Dynamic Ratings Breaker Performance Monitor helps breakers remain in optimal operating condition, improving both the safety and reliability of the electrical grid.